anyone need any bit of number 4 done? 5, 6, 7, 10, 11. We're all good? Excellent. Right, okay, we're sure we're all good? Right, okay, so what I want to talk to today is, it's still on the same section, so I'm still on limits, okay, but I want to talk about continuous graphs, okay, so what I'm going to do is I'm going to leave you write this down first, and then I'll explain what I'm talking about, okay, so I'm going to leave you write this down first, and then I'll explain what I'm talking about, so you can just, continuity. A function is continuous if it can be drawn without lifting the pen. And then here's the rule. If a function is continuous, right, this is the rule. Right, are we good? Right, so a function is continuous if it can be drawn without lifting the pen, okay? So I'm just gonna, you needn't draw this down, okay? Right, this function, that's continuous, right, okay? Because I just drew the whole out without lifting the pen, right, okay? Right, when you draw a function, you could have it like, there's ones that would be like this, right? I lifted the pen, it's in two separate parts, isn't it? Right, sometimes you can have a function, it goes to there, and then you might have to, and the next bit goes across there. Okay, I had to lift the pen, yeah? Okay, so continuous, not continuous, just some examples, some drawn out in the book. These are all not continuous, okay? So these are not continuous functions. See the way that's not continuous? So if you were to draw that, you'd have to lift the pen, wouldn't you? And start again. Okay, not continuous. These are all not continuous. See this one? It's in two separate parts. Two separate parts, you'd have to lift your pen in order to draw it. Same here, two separate parts, right? Okay. This one, if you were to draw it over here, it would be in a separate part again, right? Okay, so it's not continuous. This one is three different parts, so it's not continuous. Okay, that one down there, right? Not continuous. You see the way you can have a not continuous graph. Do you understand what I mean by continuous? Right? So continuous means you can draw the graph all in one go without lifting the pen. If it's not continuous, right, the graph is split into two separate parts, or even three, or four, or five, or whatever. Okay? Is that alright? So you'd have to lift the pen and move it to another place to draw the rest of the graph. Got it? Do you know what continuous is? Right. How do you figure out without drawing the graph? You know by looking at the graph whether it's continuous or not. Right? Okay, so we can look at that graph and say not continuous. Right? Okay, because it's in two separate parts. We can look at this graph over here and say that is continuous because I can draw it all in one go, can't I? Right? I can draw it all in one go, so it's continuous. Okay? Right. So, you know by looking at them. So how do you know, right, how do you check out whether the graph is continuous or not without drawing it? Okay? So what you have to do, if this holds true, if the limit as x tends to a number of f of x, of the function, so if you get the limit and you get an answer, right, then you get f of a, as in you put in the number for the x and you get an answer, right, then it is continuous, right? So if you get the limit as x tends to the number, if that's the same as filling in the number, right, it's continuous. If it isn't, it's not continuous, right? Okay, so my examples here are, there's two different functions here. Okay, sorry, I am, thank you. Right, two different functions here, right? Okay, here, if I get the limit at x tends to 2, so how will I get the limit as x tends to 2 of that? What do you just do? Fill in 2 for x, isn't that right? Okay, so that would just be 2 squared, right? Okay, so that would be equal to 4, right? That's one half of the sum done, right? The other half is if I just get f of 2, as in fill in 2 for x, is the exact same thing. So 2 to be squared, and we get 4. So that just means the limit as x tends to 2 of x squared is equal to f of 2. So that means it is continuous. Right, where is this one? Over this side. Okay, if I don't bother with the limit, right, okay, because if I fill in for 2, if I get the limit, or even if I get f of 2, it doesn't matter which one I'm doing because I'm filling in 2 for x, right, you get 2 minus 2, which is 2 over 0, right? If it was 0 over 0, it's indeterminate, but 2 over 0 is infinity, right, or it's undefined. So if you were drawing that graph, you get at the point 2, you'd be drawing to an undefined number. You'd be drawing to infinity, wouldn't you? Okay, which is not, that's not a real number. Undefined is not a real number, so therefore it's not continuous. Okay, is that alright? So if you're trying to draw an undefined number, obviously you can't draw it, so therefore it's not continuous. It doesn't exist. Right, okay. An example where let's see. Yes. There's no example in this book. Okay, example. 3, so that's example 1 and 2, example 2 maybe, right? Okay, so what I'm looking for is the x value for the function. This function is not continuous. Okay, this function is not continuous. So I want to know at what point is it not continuous, right? At what point do I have to lift the pen? Okay, so what you do is, if it's not continuous, girls, whatever's underneath the line is equal to 0. Okay, because you want it to be undefined at that point. So in order for it to be undefined, you want to divide by 0. So whatever's underneath the line, you let it equal to 0. Is that alright? Okay. So you want it to be, for it to be undefined, you want it's undefined where at 5 over 0. Is that okay? Right. So you let what's underneath the line equal to 0 to find out what point that is. So you let each bracket equal 0. So you get x is minus 5 and you get x is equal to plus 5. So at those 2 points, the graph is not continuous. So at minus 5, it's minus 5 undefined and it's plus 5 undefined. Okay? So that's all that question is. Is that right? So if it's not continuous, underneath the line is 0. You're dividing by 0, which gives you an undefined number or infinity. Right? And you can't draw infinity because it doesn't exist. Right? Is that okay? Right. So underneath the line equals 0. It sounds very complicated, but it's actually quite straightforward. Is that alright? Okay, are we good with that? Okay, so what I want to do is start explaining now what the hell we're doing when we are differentiating. Okay, so we know how, right? Now we're getting into the why. Okay, right, so I'm going to say average rate of change. Right, is equal to the slope. Okay, so average rate of change is the slope. So when you're getting the slope of the line, you're actually getting the rate of change of y. So the slope is equal to the rate of change of y with respect to x. And that's fine if it's a line. You needn't bother drawing the line now because it's just me drawing a line. It's fine if it's a line, right? Okay, you can get the slope of a line, can't you? Right, use the slope formula, get the slope of a line. You all know how to get the slope of a line? Please God. Right, okay, the problem comes, right, okay, when you have a curve, right, okay? Because you can't get the slope of a curve, right, okay? Because the slope of the curve is actually the slope of the tangent at that point. So the slope of that point is that slope of that line. The slope at this point is the slope of this line. So the slope keeps changing, doesn't it? So that means the rate of change keeps changing. Agreed? Okay. But what you can do is, right, okay, if you have 2 points on the curve, and I call it A and call it B, right, so we're not drawing the line, we can draw that. If we joined A to B, we can get the slope of that line, can't we? And that's called, if the slope of this line is the average rate of change between A and B. Slope of this line average rate of change between A and B. So you can get the rate of change at A, because it's the slope of the tangent there at A. You can get the rate of change at B, right, okay, and if you join the points A to B and you get the slope of that line, you can get the average rate of change from A to B, right, okay. So differentiation is going to allow us to find the rate of change, okay. So what I need to do is, right, okay, is I need to put this on points. I need to actually draw a graph and put some points in here, right, okay. So if I have, right, I might go, can I take this away? Is that okay if I take it away? Right, okay, so if I draw a graph here, and I'm going to have, I'll draw a curve there, okay, and I'm going to say that's X, and then, yeah, so this is the point X, Y. So instead of Y, I'm going to put F of X. Is that alright? F of X. So I'm using F of X instead of Y. Is that okay with everyone? That's our point there. Right? Okay. Then I'm going to move up, right, a distance of H. Right? So I'm going to move up a distance of H, and I'm going to have another point. So if that's X, this one up here would be X plus H, wouldn't it? Right, okay, so the point would be X plus H, what? F of X plus H. Right? As in, if this was 4, this would be 4y, right? Okay? If this was 6, this would be 6 f of 6, wouldn't it? So this would be 4 f of 4, wouldn't it? This would be 6 f of 6, etc. Right? If you just put a number on it. So I'm just being big and putting x's on them. Right? Okay? So I have moved up from that point to that point. So x, random number, x, and the y value is f of x, isn't it? You'd fill in x for x into f of x into the function, yeah? Agreed? Right here, I'm just going to move the x up a little bit, so I'm going to call the distance I'm moving it up h, right? Okay, so this is now, the x value is now x plus h, because I moved it up, however many steps I moved it up, and the y value is f of x plus h, yeah? Okay, and I want to get the average rate of change. So the average rate of change, how do I get the average rate of change, please? That's another way of asking me to get the what? To get the slope. Okay, so average rate of change is the slope formula. So it's y2 minus y1 all over x2 minus x1. Agreed? Right, okay. So x1, y1, x2, y2. Right, fill in, right, so it's y2, which is f of x plus h, minus y1, which is f of x, right, all over x2, which is x plus h, minus x, right, wouldn't it? Using those points, are you all with me? Right, I know I've lost some of you, but is somebody with me? Are we okay? Right, so the slope of that line, girls, is, I can't simplify on top, so it's basically y2, take away y, the y value of the first one, all over h. Agreed? Okay? Right. But what if I made h smaller? Right, so that's the slope of this line that's going through those 2 points. What if I made h smaller? Okay, so that's not the slope of the curve, right? Okay, but what if I moved h nearer? So h comes down here, then h comes here, h comes here, h comes right alongside it. So basically, as h gets smaller, it's basically coming near the tangent, isn't it? Okay, so as that gets smaller, the slope, the average rate of change is coming near the slope of the tangent. Would you agree? So as that gap gets smaller, right, okay, that point moves closer and closer to that point, and the average rate of change moves closer to the slope of the tangent at that point, doesn't it? Okay, would you agree? So basically, if I got the limit as h tends to 0, so h is getting smaller and smaller. If I got the limit of this value, where h is getting smaller and smaller, I'd actually be getting the slope of the tangent at the point x. So as I move that point nearer and nearer back here, right, it nearly ends up on top of the other point. I end up, the slope gets nearer and nearer to the slope of the tangent, right? So if I get the limit, where is it heading for? That would be the slope of the tangent at that point. Agreed? Okay? That's differentiation. That's what we're doing when we're differentiating. We're actually doing this, right? But the rules are a shortcut to do this. Okay? So they've come up with shortcuts for us. So we're actually doing this. Now we have to learn how to do it out the long way in a few minutes. Right? Okay? But we only learn how to do it out the long way for a couple of different functions. And after that we can use the rules. Right? Okay? So the rules are basically a shortcut to do this. So this is what we're doing. Every time we differentiate, this is what we're doing. Right? So what you're actually doing is you're getting the slope of the tangent at the point you're talking about. Okay? Right? So every time we differentiate, this is what we're doing. Right? All the great mathematicians in the past came up with shortcuts for us. We love them. Right? Okay? So they came up with shortcuts for us. Right? But this is what you're doing. So every time you differentiate, this is what you're doing. And what you end up with is, you end up with this. So you start with a curve and you end up with the slope of the tangent at a particular point. Okay? Right? So doing it out the long way is called differentiating from first principles. Okay? Now if you don't understand the theory behind this, don't worry about it. Right? Cut to the chase. Can we do limits? Yes. Can we differentiate? Yes. Can we differentiate from first principles? We will be able to by tomorrow. Okay? Is that alright? Okay, so if you don't understand what I'm saying there, don't worry about it. Cut to the chase. Right? Okay? So this brings me to differentiating from first principles, which is the long way around of differentiating, right? And it's where all the mathematicians did at the start. Right? Okay? But then they came up with shortcuts for us. Okay, so we have to learn the long way for simple. We have to learn the long way for simple differentiation. But after that, we can use the rules for all the long ones. Okay, so it's called differentiating from first principles. Okay, and we're basically going to fill in this formula. Okay, so I'm going to go straight to an example. How am I going for time? Because this is going to take a bit of time. 11:36, I'm okay, I'll get it. Okay, right. Okay, so example 1. This is how we do it, cut to the chase. Okay, so example 1. Differentiate two x minus 4, sorry, I should go f of x. Right, differentiate 2x minus 4 from first principles. We know the answer. We know the answer. If I was to differentiate that, what's the answer? 2, isn't it? Differentiate that, you get 2, wouldn't you? We know the answer. Right, but this is the important bit, from first principles. So what we have to do is we have to remember, when I differentiate from first principles, this is what I'm doing. I'm getting the limit as h tends to 0 of f of x plus h minus f of x divided by h. I'm basically getting the slope, using the slope formula, and getting the limit as h tends to 0 of that. Okay? So what I need to do is I need to work out all of these. Okay? So I need to get f of x plus h. How do I get f of x plus h? Into the function, everywhere I see an x, what do I put in? X plus h, isn't it? So the function is 2x minus 4, but I'm going to put 2x minus 4. Is that alright? Okay, that's the first bit. That's f of x plus h. Would you agree? Take away f of x. What's f of x? 2x minus 4. Why did I put it in brackets? Why did I put that in brackets? Because of the minus. The minus is going to change all the signs, isn't it? Okay, and then I'm going to divide that by h, and then I'm going to get the limit of that as h tends to 0. So I got f of x plus h, right, by filling in, instead of x, putting in an x plus h. I take away f of x, which is my original function, and I'm going to divide it by h. Why? That's the rules, right? Okay, so I'm getting the limit as h tends to 0. I'm going to do that near the end. For the moment, I'm going to get rid of all the brackets, so I'm going to multiply in there 2x plus 2h minus 8 minus 2x plus 4. Agreed? And I'm going to divide that all by h. So all I've done there is multiply into the brackets, right? And the minus just changes the signs in the second bracket. With me? So that would be tidying up that as h tends to 0. And just algebra, I'm just tidying up 2x minus 2x gone. Why is that? Yeah, it's fine. Right, I end up with a yeah, why did I do that? That was just stupid. Sorry, I knew there was something wrong. Okay, sorry, I didn't need to multiply that 4 by 2 because the 2 was only. Is that right? I knew there was something wrong there. Right, is that okay? So the 2x minus 2x gone. The minus 4 plus 4 gone, so I'm left with a 2h on top. And I have a h on the bottom. Agreed? So that would be the limit as h tends to 0. I can just divide 2h divided by h is 2. So the limit is 2 as h tends to 0. There is no h, right? So the limit is just what? If I was to do this, I'd fill in a 0 for h, but there's no h there. So the limit is just 2. That's my answer. You told me already, when you differentiate, that's what you get. Okay? Right. Bear with me. Okay. Can I take that away? Is that right, everyone? Right, here we go. I'll do a second one. Differentiate 3 minus 2x from first principles. Right? Okay. We know the answer before we start. What's the answer going to be? Minus 2, isn't it? Minus 2, the number in front of x. Differentiate 3, you get 0. Differentiate minus 2x, you get minus 2. The answer is going to be minus 2. Agreed? Okay, so I have to fill in this formula. Where is this formula? I need to remember it. It needs to be in my head. It's not in the log tables. So this here needs to be in my head, right? So I have to do f of x plus h. So what would that be? Everywhere I see an x, put in an x plus h. So it's 3 times minus 2 times x plus h. So that's f of x plus h. Agreed? Then it's minus f of x. F of x is what you started with, which is 3 minus 2x. And that's all over h. Okay? Alright? Multiplying out. So we get 3 minus 2x minus 2h minus 3 plus 2x all divided by h. Okay? Right, simplifying that, tidying it up, h tends to 0. So 3 minus 3 gone, minus 2x plus 2x gone. I'm left with a minus 2h on top and a h on the bottom. Divide each term by h, so you get the limit as h tends to 0 of minus 2. And what is the limit? It is minus 2. Okay, right, I'm going to ask you to try those. I know we've only started them, but let's have a go at page 273, question 1. Right, so page 273, question 1, it's not a lot, okay, so take the time to try and get your heads around it, okay, so take the time to try and get your head around it. Yeah, put up the photo, yeah.